workshop is not just about acquiring knowledge, it's about empowering our teaching community, it's about equipping our educators with the tools and insights they need to inspire the next generation of scientists and innovators. Together, let us explore the frontiers of science and technology, and together, let us shape the future. Before we proceed further with our agenda today, I would like to take a moment to acknowledge the presence of our esteemed chief guest, Dr. Vishwas A. Papat sir. To describe sir in just a couple of words is a highly impossible task for such as sir's dynamic personality. But if I have to convert sir's introduction, I can only resonate with two phrases. Dr. B. A. Papat, esteemed plant biotechnologist with extensive contributions and distinguished scientific leadership.
Though we normally say Bengaluru has a very salubrious climate, considering that there is a lot of heat outside, when you come inside our campus, it is indeed a cool climate. There is a lot of good green vegetation at BMS ITNL. It's very heartening to see the hall full. Probably this after a long time, much after COVID, we have started most of this and all our activities have resumed in the offline mode. I compliment Dr. Bhuvaneshwari for having brought this type of a program to BMS ITNL from Indian Academy of Sciences, Bangalore. For a short introduction of the chief guest, Dr. Vishwas Papat sir. Sir has served as a scientist at Bhabha Atomic Research Center, Bombay from June 1971 to May 2007. A long checkered career. Post his stint at the center, sir has taken up different roles as an emeritus scientist, senior scientist, honorary scientist at Shivaji University, Kolhapur. And the period is from 2007 to date. Sir is serving in all this capacity. He has a checkered 46 years of career and he has made noteworthy contributions in some of the basic strategic and applied research in development in plant biotechnology. Some of the key themes and strategies have been developed by him for micropropagation of plants using appropriate case studies. Remarkable research mainly pertains to embryogenesis, synthetic seeds and plant regeneration in sandalwood and sugarcane, including transfer of banana micropropagation technology to the user's agency. He has extensively worked in vitro mutagenesis using gamma radiation in banana and sugarcane for induction of novel genetic variability. His major contribution also is for design of gene constructs for plant genetic manipulations for specific targets of disease resistance and molecular farming, which is a very praiseworthy work carried out by him. Some of transfer of coat protein antimicrobial gene to potato and banana respectively needs special attention. Expression of hepatitis B surface antigen in banana, potato, soybean is a significant milestone in the development of edible vaccines. The list goes long. I heartily welcome you, sir. Even we appreciate your enthusiasm and your effort to also enlighten us, share your research thing with our group of researchers, students and staff at BMS ITNL. I welcome you to BMS ITNL.
Chief guest of this function, Dr. Vishwas Papat sir. Then I would like to invite one more guest who is a speaker, Dr. Manish Kokre. Sir is director at Nanded University, Guru Govinda College of Engineering, Nanded. But still we managed our Department of CSE with the support of all the faculty members and our HOD and also our vice principal's guidance, I could make this a success event. So there are totally 22 participants are there from outside, and 2 participants are yet to come from Central University, Punjab. And there are 14 sessions in this workshop. Each day there will be 4 sessions. Then totally there are 48 sessions will be there. The speakers are from Punjab University, Patiala, then Shivaji University, Kolhapur, then Nanded, Kokre sir, just now I said. Then 2 professors are from IISc Bengaluru, Dr. Chetan and Dr. Jayant Harshit, and Vivek Porkar sir is from IIT Bombay, and 2 persons are from industry are there. So I request all the participants to best utilize the refresher course. The main purpose of the refresher course is to enhance the knowledge and skills of the faculty members. This is mainly oriented for faculty members, but even students are also allowed. I asked the academic people whether our MTech students can participate, and they said they given permission, and I am very much thankful to our principal sir. So I am thankful to you, sir. So I request all the participants. There are 5 technologies are there here. Artificial intelligence is there, IoT is there, cyber security is there, ethical hacking is there, open AI is there. So all the top level current technologies has been taken up here for the execution. So best utilization of this. So accommodation, food, everything is provided for all the 12 days. So I am thankful for the science academies for providing all the facilities for the execution of such events. So best of luck everyone. Thank you one and all.
This course is a chance for us to challenge ourselves and broaden our ideas. Today's refresher course is an important event for all of us, and it will give us the valuable insights and information on a topic which is very, very important to our education and future careers. The theme of this course is interdisciplinary cutting edge technology in science, and we have gathered some of the most knowledgeable and experienced speakers to speak to the participants. Science and technology are progressing at breathtaking speeds. Innovations, new ideas and concepts are changing our lives and opening vast opportunities. Technology is the practical application of science that improves the quality of life. Whereas science is a systematic approach that uses observation and experimentation to gain information and develop the technologies. Technology is a product of systemic approaches, which is what is there. Technology development also follows scientific progress, and latter is good for the logical consequences of the founder. Engineering and life sciences are merging for the development of the desirable technologies. Exciting and remarkable products are in the market, generating new avenues for the business class. Being a biotechnologist, I will talk on engineering biotechnology in my lecture. As you are aware, biotechnology is called as fourth wave of innovation and encompasses medical, agriculture, plant and animal sciences, macrobiology and various marketed biotech products. It is a right place to thank the science academies. We have 4 science academies in India, and they are funding this course. Science academies have different objectives, and the main job is to promote scientific knowledge in India that includes practical application in the national welfare. The importance of this event cannot be overstated, and I would like to take a moment to appreciate the hard work, dedication and time spent by our organizers in putting this together. They have worked tirelessly to ensure that everything runs smoothly and very correctly. And I would like to thank them for their important and hard work. I would also like to remind you all that this refresher course is not just about learning from experts, but also about networking and building the connections. We have the opportunity to meet and interact with other students and speakers who share our interests and passions. And this connection can be very precious in our future careers. In conclusion, I would like to thank all of you for being here today, and I hope that we will make the most of this event to learn and grow. Thank you very much.
We all know that the technology is changing in a rapid pace. It's very important for us to have the information on that. In this regard, Dr. Bhuvaneshwari, the Professor of Computer Science and Engineering, has taken the pain to organize this 15 days workshop. We all know that organizing a 1 day or a 3 days workshop, we struggle. But organizing a 15 days workshop, it's very difficult to get the participants and also difficult to identify the eminent resource persons. So we have one of the eminent resource person, Dr. Manish Kokre. Again, the resource persons are there from different parts of India. Eminent resource person like Dr. Jayant Harissa, he is a Dada in databases. So we all know that the curriculum, again, the pace in which the technology is changing, the same speed we are not able to change the curriculum. Yes, we are working hard, but when we design a curriculum at the university level, they have to, if we take an example of Vishweshwarya Technological University, so they have to consider all 220 colleges while designing the curriculum. But as an autonomous institution, the BMSITM is an autonomous institution, and by the vision is by 2030, all the engineering colleges need to become autonomous. That is the vision of UGC. So that the curriculum design will be in our control. Okay, so even though we can change the curriculum every year, but it is not possible to meet the technology change. In that regard, it's very important for our faculty members to understand what is the current technology. Okay, so based on that, they have to fine-tune their teaching learning practices and the curriculum. So as per UGC, all the faculty members are a board of studies members. So you need to contribute for the curriculum. So when it comes to the topic, interdisciplinary cutting edge technologies, as our chief guest rightly pointed out, there is a war between the departments. So first we have to think about between the departments, then we have to think about between the organizations. There is a war. Okay, the faculty members and students need to talk with the other discipline departments. So the most of the time I have seen, so even the computer science and engineering faculty or student will not talk with the AIML faculty and students. So there is a wall. We have to break that wall. Okay, so we need to, as a computer science engineers, we need to talk to the biologist, we need to talk to the civil experts, we need to talk to mechanical experts, healthcare. So we need to understand the different domains. Then only we can give a effective and efficient solution to the society. Okay, so in this regard, from next academic year onwards, from 24-25, at the department level, whatever the projects we have, so we want to have 25% of the projects in interdisciplinary areas. Again, the project team need to be interdisciplinary again. So we may have 2 students from computer science and 2 students from mechanical, again civil, electronics, electrical. So 25% of the project need to be in interdisciplinary area. So I request HODs and the faculty members to take these steps. Again, create awareness among the students to talk to the other discipline students and form a team, and the problem need to be in interdisciplinary area only. Again, we have already taken steps to have 25% of the projects with the industry. The problem will be defined by the industry. There will be industry mentor and also the mentor from the BMSIT. So we want to have, that is, our students are going to take up the industry-driven problem statements. So finally, I want to thank HOD CSE, the faculty members, for organizing this particular event, and my special thanks and pranams to Dr. Bhuvaneshwari for taking the lead. Thank you.
Today we gathered here and the program of inauguration of this particular refresher course is being completed. Any program will always start with inauguration, followed by sessions, followed by valedictory. So thanks for everyone who supported directly and indirectly to make this inauguration program grand success. Thank you very much.
It's decided by number of independent variables used to represent that signal. So how many variables are independent variable in this signal representation? Only one. So this signal is called as a one-dimensional signal. Now speech, if I record that speech with, okay, it is basically time and then amplitude. So speech is a one-dimensional signal. Okay. Suppose for example there is an earthquake and we measure the earthquake with the help of seismography. So seismic signal will be also recorded with respect to time, so amplitude of that. So seismic signal is one dimensional. ECG. ECG is of heart now. So ECG will come like this now. With respect to time. So ECG is also one dimensional signal. EEG, electroencephalogram. Okay, brain signal. That is also one dimensional signal. Okay. Then if you measure the, so for example, temperature of the Bengaluru city, hourly temperature at 7 a.m. temperature, this one at 8 a.m. then 9 a.m. then this one, so that way. So what it will be? Time and amplitude. So that temperature signal will be also one dimensional signal. So this is one dimensional signal. Now, when you take the picture, so what will happen basically? Light from the camera will fall on the source and then it will be reflected back and then it will be recorded on X and Y grid. Okay, X and Y grid. So, see that. You will see this one. Okay, so X and Y grid, and on X, every X and Y grid, this reflected light will be recorded. That is called as the pixel coordinate, and the recorded value is called as the pixel intensity. So now here there are how many variables? Only two variables. X coordinate is there, Y coordinate is there, and intensity is also there now. intersection of this x and y where you are recording the intensity. So I is intensity, x is x coordinate, y is y coordinate. So how do you remember the image or represent the image? I of x comma y, right? So how many variables are there in that? Three. One is x variable or x coordinate, another is y variable, and third one is I. Now here x depends upon y or I. X is independent, y is also independent, and I depends upon the value of x and y. So for example, reflected light intensity at this location is my hair. Okay, it is black now. Now black color reflects more light, it absorbs more light. So reflection will be less. So reflected intensity will be less. Okay. Then if you come down, it will be grayscale. If you are white, more reflection will be there. If you are dark, then it will be less reflection will be there. If you come down, white shirt is there, so more reflection will be there. If you come down, black pant is there or blue pant is there, reflection will be less. So depends upon the location, whether x coordinate, what is the value of x and y, intensity will change. So intensity depends upon the value of x and y, but x and y doesn't depend upon the value of other two. Right? So how many independent variables are there in this signal representation? Two independent and one dependent. Two independents, x and y, and one dependent is nothing but the I. So how do you say that? Image is two-dimensional signal because there are two independent variables which are used for presenting that signal. Right? Now, okay, so this is image, and if you see the video, how video is recorded? If you capture the image, it will be a single frame. But for video, now this video camera is there. How does it work? See that. It works on our vision principle. Okay. If you hold any object in front of your eye and if you remove that object, what happens basically in our eye? So the image which is there, it will remain on retina. If I remove that image, if I remove this object, still for some time this image will be there, and that is called as the persistence of vision. And how much time it remains? It remains 1/16th of second, 1/16th of second. So that much time that image will be there in a human retina, even if you remove the object.
Is it illusion?
No, illusion is different. Okay. This is called as the persistence of vision. This is called as the persistence of vision. And by using that one, okay, by using this principle, the video camera is developed. Okay. Because what is changing digital image and video image or video this one? What is change? In digital image, if I capture the picture, what I'll get? I'll get only the simple things. Nothing. If your position is like this, you'll get like this. If somebody is like this, but can I capture the motion of the object? So for example, I'm moving my hand from this location to this location, and this motion should be captured with the help of still image. It is possible? No. I'll get image like this or this or this or this or this or this, like that. Okay, and that is what this persistence of vision plays the important role. What is very? If you play this simple, for example, this one frame, this another frame, this third frame, fourth frame, like that way. If you play the frame such that 16 frames per second, then because you will get the continuity of your image, and you see that your hand is moving. So motion effect you get that. So minimum 16 images should be there in a second to get the motion effect. But there are two standards. One is PAL standard and another one is NTSC standard. PAS standard is used by European people or Asian people, and NTSC standard is used by American. Why? So in PAS standard there are 25 frames per second for recording, and for NTSC it is 30 frames per second. Why? We need only 16 as per persistence of region. And you might have seen that slow motion, or you might have seen that some fast motions also. Means what exactly you are doing? In slow motion, number of frames per second are less in that form. Now, 25 frames per second and 50 frames per second. Now, see that you have electricity now. This point is there. What is the frequency of this? 50 hertz, no? It is 50 hertz. If you go to US, what is the frequency of that circuit? 60 hertz. Right? Now, if you transmit the images or video, then you get the flicker noise. You get the flicker noise, and to avoid that one, the frequency of your transmission is basically capturing the image, and this electricity AC frequency is matched. Now here we are saying that 25 frames per second, but in one frame there will be two interest frames are there. So one is divided into two, that is, okay, scanning is done first, odd scanning is done, and then even scanning is there done. So there are total 2 frames, 2 scannings will be there, and then that frequency 25 into 2, that is equal to 50, which matches up with our AC frequency, and that avoids the flicker noise. If you go to US, it is 60, so 30 into 2, that is equal to 60. So that way it is matched, and to avoid the this one. So here 30 frames per or 25 frames per second are there. Now see that in a single frame, how many variables are there? 3 variables are there. One is X, another one is Y, and third one is I. Out of that, X and Y are independent, and I depends upon X and Y. Now here, in a video, there is a third axis which is called as the temporal axis. Okay, so see that these frames are there, right? So these frames are captured in such a way that in 1 second, 25 frames should be there, and then it is played with the speed of 25 frames per second, and then we get the motion effect with that, right? We get the motion effect, and this I said that this is related with your persistence of vision, because we hold any object on our retina for 1/16 second. Now here there is a third axis. What is that axis? Temporal means time axis. So how many variables will be there to represent the video image or video signal? 4 variables will be there. One is X, another one is Y, third one is time, and fourth one is I, intensity. Now this X is independent, Y is also independent, time is also independent, and I depends upon the value of X, I depends upon the value of Y, and I also depends upon the value of time. So there are 3 independent variables. That's why video is considered as a 3-dimensional signal. Video is considered as a 3-dimensional. Simple image is considered as a 2-dimensional. Okay, and speech is considered as a 1-dimensional. Now, what is the domain of speech signal? How do you represent? What is the this one? Independent axis. Time na. So that representation is called as the time domain representation. Domain of speech signal is time domain. But when you represent the image, image is represented in a space, and space coordinates are X and Y, and that's why, okay, domain of image is spatial domain. That's why it is called as the spatial domain signal. If you come to the video, X, Y, and T. So X and Y are spatial coordinates, and T is the time variable. So the domain of video signal is spatio-temporal domain. So image is video is represented in a spatio-temporal domain, image is represented in a spatial domain, and speech is represented in a time domain. Now in my next session of wavelet, I'll see the frequency domain, why we are going from one domain to another domain, and so on. So this is video signal. Now, the real world image which is captured with the help of camera and then digitized and image is formed and so on. Now, what is this image? Huh? Is this? Those who are working in the image processing or computer vision or machine learning, AI people, they must know. Huh? She is very famous, na?
Yes.
Her name is? Shilpa Shetty? She is not Shilpa Shetty. Vipasha? No. She is Miss Lena. Now she is Grandma Lena. Because this picture was captured in 1972 when she was young. Now she is old. Must be Grandma, na? And this was published on a magazine as a front page. Why this image is used as standard image? Because it contains maximum spatial frequency, and to test the image processing algorithms, this image is more suitable, and that's why for image compression or any other image processing, okay, this image image is used as standard image for testing the image processing algorithms. Now see that. So grayscale image already I talked about, binary image I talked about, color image I talked about. So any image represented the I of x, y, where x and y are the independent variables and I is the dependent variable. Okay. So this representation of that one. Color image. Now see that. Which basic colors are used? RGB. Okay. In rainbow, how many colors are there? 7. Which are those? Big part. Then out of 7 colors, why you are using only RGB? Why so much love is there with RGB? High intensity. Oh. Okay, so let me know. Why RGB? Why not all those 7 colors are used for representing the image? Or there are several colors, no? What is so special about the combination of these three can produce the I told you that, okay, with the help of your camera, you capture the beautiful picture. Okay, and the wavelength of that camera is, what is the wavelength of that camera? 400 nanometer to 700 nanometer. Okay, now see that red color. What is the wavelength of red color? What is the wavelength of green color? And what is the wavelength of blue color? Blue color wavelength is around 430. Red color is around 550 and green color is around 650. So it falls within the visible spectrum. So with the help of RGB, we can form the any color which we can see as a human being. Okay, and that's why it is called the primary color of light to visualize the things. So with the help of red, green, and blue, we can form the any color combination. Now same color is used for printing also. Okay. Cyan, magenta, and yellow. Why RGB is not used for printer? It is used for only display purpose. Have you seen the toners of color printer? How many toners are there? Have you opened that one or not? No. Hope you have seen the color printer. Yes. Okay. Only signal. Okay. Command is given in the computer, and then you get the nice print. But you haven't opened the printer. So there are 4 toners. If you open, you'll see that there are 4 toners. Now see that these toners are not RGB. It is CMY. Cyan, magenta, and yellow. Because cyan, magenta, yellow are the primary colors of pigments. Cyan, magenta, and yellow are the primary colors of pigments. Okay. As sir said that if you mix RGB with maximum quantity like 255, 255, 255, you get the white light. Okay. white light. And if you mix C and Y in equal combination, then you should get the black, which is exactly opposite. But if you do that one, you don't get perfect black, you get the muddy black. And if you would like to print, you don't get the black color. And that's why additional toner is there, that is the black color. So C, M, Y and B. Now, CMY is used for printing purpose, whereas RGB model of color is used for display purpose. What about the transmission? When you transmit the image or video from one place to another place, whether they use RGB or CMY? No, they don't use that RGB or CMY. There is a YCRCB model which is used for transmission purpose. YCRCB model is used for transmission purpose. What about the human being? How do we perceive? In which color model we perceive the image? Okay, in our retina, there are cones and rods. Cones and rods are there. Cones are for black and white, and rods are for color. Everybody agrees with that one? Or it is exactly opposite? Cones for black. Chromatic information or achromatic information? Cones are for color information. There are three types of cone in our retina: red cone, blue cone and green, RGB cones are there. Okay. And so three types of cones are there, millions of cones are there, and also rods are also there. Rods, okay, are used for measuring the intensity part, and cones are used for the chromatic part, that is color information. Now, so three types of cones are there means, suppose for example, if you consider 100 cones are there, out of that 100 then 33.5, 33.5, 33.5, is it like that? Is a linear combination? No. 66% cones are red cones in our retina. 33% cones are green cone, and only 2% cones are blue cone. But if you do the survey of the entire world, which color is generally preferred by many people? Survey says that many people like blue color. Blue is the success of color of success color, na? Red color is used for something different. Okay. But actually in our retina there are only 2% blue cones. Red cones are not. Though we have RGB cones, but that is in retina, na? Image is perceived in the brain. And when you are perceiving the image in the brain, this RGB model doesn't work. There, HSI model is used. That is hue, saturation and intensity. HSI model is used for perception of the image by the human being. So see that. For display purpose, you use the display means your monitor, computer monitor, and this display also. RGB model is used. For printing purpose, CMY model is used. For transmission purpose, YCRCB model is used. And for perception of the image by human body or human being is HSI model. And that's why there are several color models in the image processor. Now, lunchtime? Okay, so we'll stop here and then we'll continue. Are you getting or not?
Yes, yes, sir.
Okay, one-dimensional signal will say that it's not an image, it is a one-dimensional signal. Two variables, one is time variable and another one is amplitude. Is two-dimensional means two independent variables. Okay. The dimension of the signal is decided by how many independent variables are used to represent that signal. In speech, only one independent variable is used, that is time. in case of image, two independent variables are used, that is space, x and y coordinates, and in video, x and y coordinates plus time, that is spatial temporal. You are saying something?
Number of dependent variable is it one or multiple?
One.
Yes, always
Yeah,
one.
see that?
Any
Yes. Your amplitude, in case of one-dimensional signal, amplitude depends upon the time. In case of your two-dimensional signal, that is image, what is variable? Basically intensity. Now intensity depends upon the, as I said that light reflected from this position, okay, it is black right now, so it will be less. If you come down, it will be more. So location of x and y is different. Or so for example, if I consider here like this, location of y may be same. Location of y may be same, but location of x is different now. So intensity depends upon the value of x, intensity depends upon the value of y, intensity, okay. So like that way. Similarly, when I capture the image, first frame in the video, at time t equal to t1, so like that way. So my hand is in this position. At time t equal to t2, hand is in this position. At time t equal to t30, my hand is in this position. Now, see that intensity which is recorded will be different now. Because earlier there was no hand in this, so reflection will not be there. Now there is a gap between this one and this one. So between x, it varies between x, y, and time. But which is dependent variable? Intensity. And independent variable will be many, and that independent variables will decide the dimension of the signal, and in which domain you are representing. So that will decide the domain of the signal. So these are the original domains of that. Okay. And now people are shifting from original domain to another domain. So why we are shifting from original domain to another domain? Then we'll see later on.
In video, then we are completely ignoring the intensity. Only temporal is the.
No. How we are? See, intensity is recorded now
Yes.
with respect to time and x and y coordinate now. See that? That's why I said that. Okay, my first frame is like this. Okay, time t equal to 0. X y coordinate is there. Time t equal to 1. T equal to 1, I got x y coordinate intensity. So like that way. So intensity is recorded with respect to x, y, and t in case of video. And then he will tell whether you are on right track or wrong. If you are on the right track, definitely he will appreciate you. If you are on the wrong track, then he will fire you. Means after getting the first iteration result, you get the feedback from the supervisor. If you are on the right track, you will go ahead. If you are on the wrong track, then you will try to correct it. And then again you will present the result to the supervisor. Supervisor will see whether it is right or wrong. Again if it is wrong, then again you will get, okay, you will fire. Again you have to correct it. And then unless and until you are corrected, you will not go forward. The same is the thing in the reinforced learning. Okay, you have to learn, and then you have to present the result, and then after that you get the feedback. If you get the positive feedback, you can go ahead. If you get the negative feedback, you have to correct it, and so on. So, this is the difference between supervised learning, unsupervised learning, semi-supervised learning, and reinforced learning. Now, this machine learning may be classified into three types. One is supervised, unsupervised, and reinforced. So supervised learning is further classified into two types. One is the regression approach and another one is classification approach. Means where your output is in analogous form or in continuous form, then it is a regression, and it is discrete form. Like for example, this is a remote, this is a discrete, this is raster, this is a discrete. So it is a classification approach. So the main difference between regression and classification is that in a regression you have output in the analog form or in continuous form, and in classification your output is in discrete form. Now see, for example, this BMS college, it is having a total land of 21 acres and several departments are there. And we would like to predict that on March 26 in 2028, what will be the electricity load required for this college at 2 p.m. Can you predict? Is it possible or not? Is it possible? Yes, it is possible. For that, what do you have to do? You have to develop the prediction model now. You have to develop the regression model. And for developing the regression model, you should have the previous data. Like for example, I have previous data of 5 years, and that data is like, for example, hourly data at 7 a.m. what was the electricity requirement? At 8 a.m. what is the electricity? So like that way, for 24 hours, 7 days, weeks, okay, months and yearly, I have that data. And then I know that on 26th March 2020 at 2 p.m. what was the electricity? Then 21 what was the electricity? 22, 23, 24 and 25. I have previous 5 years training, and then from that training I can predict what will be the electricity requirement. Okay. So this learning and prediction is nothing but regression. So in that case, suppose for example, in my center of excellence, we have a center of excellence in signal processing area. Okay, I got almost 7 crores for installation from the middle of the year. And we are working environmental field in that. So one team with me is working on direct rate, another team with another professor. That team is working with brain tumor and so on. Tumor side. And we have collaboration with Avalahalli hospital in Mumbai. And then we have developed a model that if someone is suffering with brain tumor, now this regression model is predicting the life expectancy of that person. How long that person will get survive? For next 6 months, or 1 year, or 5 years, or 10 years. Based on the previous data. Now, after that, in 2018, we participated in the MICA conference at Spain. There were 64 countries, and we stood third, our model stood third there, which was impact result. Means, basically, prediction of life expectancy of humanity is nothing but the prediction model. Okay. Market forecasting, like for example, we have to forecast what will be the share value of this XYZ company. You can do it. Or weather forecasting is also example of regression. Or advertising popularity prediction is also even. Yeah, time series models. So basically here value is not discrete, it is a amorphous value. Whereas in a classification, for example, I have whether that person is a tumor, having tumor or not having tumor. This is classification. Or this is a one class of remote, another class maybe is mild, is another class, and so on. So this is discrete class. So that is a classification. So under supervision, supervised learning, there are two things. One is regression and another one is classification, where you have a prior knowledge about the samples. Whereas in case of unsupervised learning, as I said, that no data sample is labeled. We don't know how many classes are there. So by using the similarity concept, like for example, I told you the example of Amir Khan and Amitabh Bachchan. So when you are measuring the height and weight of Amir Khan and Amitabh Bachchan, so most of the samples of height and weight will fall in one cluster. Is this similarity for Amir Khan as well as Amitabh Bachchan? So forming the cluster, and similarity approach, we can classify the objects by using unsupervised learning. Similarly, in that case, another thing is dimensionality reduction. As I said that, what is called dimension? Dimension of feature space. When we took the 2 features, then feature space dimension was 2. When we took the 3 features, feature space dimension was 3. If you take the n features, then feature space dimension will be n-dimensional feature space. And for dividing this n-dimensional feature space, you need a hyperplane. Now, sometimes you might have selected 100 features, and out of that 100 features, only 10 features are important. So how to recognize which are the important features? So in that case, dimensional reduction techniques are used to select the number of good features. So that also comes under this one. The reinforced learning, as I told you that it is learning like as a your PhD student. Okay. So that is used particularly in game AI or skill acquisition or learning tasks or robot navigation or real-time decision making. And so on. Right. Now, why machine learning is becoming popular now? Okay. I told you there are three reasons. The one reason is that I just compared when I was doing a PhD at Carpool in 2001. I told you I was using 53 machine. And now machine is I7. So the power of machine is increased from 3 to 7, that is 10,000 times more powerful machines are available now. Okay. At that time, okay, data cost was very high now. Calling rate was very high. Internet data was very costly. So it was around $12.47 per gigabyte, but now it is almost 0.004 per gigabyte. So data cost is reduced. That is another reason. Third reason is that, see that since everybody is using internet and there is a huge amount of data which is available on the internet, so it is exponentially increasing. So data growth is exponential. So see that the data cost is reduced 3,000 times, processing power has been increased 10,000 times, and data is increased exponentially. Now having only data is of no use unless and until it is properly interpreted. Now huge data interpretation by using human only is not possible, and for that we have to employ the machines. And since we have powerful machines now, data is also large. Okay, that's why there is a rise of AI and machine learning nowadays. So nuclear family concept is there, and in the future, these elderly people will be alone, and to give them a security, okay, they should be connected to the doctors, they should be connected to the family member, they should be connected to the police. So all those sensors will collect the data, and if somebody calls, automatically it will be communicated to their family members, it will be communicated to the doctor, it will be communicated to the police, so that they will get the services quickly. So it is the era of intelligent machines, and by 2025, robots, machines, learning and artificial intelligence will displace for 1/3 of the job. Then most of the industry, it's not like that only E group is working in the AI machine learning, but service sector, okay, or mechanical or process industries, any industries, everyone is working in the AI and machine learning. Why? Because you get with the technology of AI and machine learning, you get the enhanced feature. You get the better, you can make the better decision. You can create the new product, you can optimize the internal businesses and so on. So there are several reasons why everyone is switching to the AI and machine learning technology and so on. Now see, this is the data of emerging technology, big data, AI, machine learning, visualization, Internet of Things, or open source and so on. So there is a huge market of this one. And the industries which are working in this AI and machine learning already are, like for example, there are industries which are working in the 123 companies are working in simple machine learning, then machine learning applications, 260 computer vision, 106 computer vision application, 83 smart remotes, then visual personal assistant, speech to speech translation, that is nothing but the natural language processing, then context awareness, okay, then gesture recognition control, recommendation engine, video content, NLP general. So there are thousands of companies available already working, and there are several startups also which are working in AI and machine learning. So, as a data scientist or AI engineer, okay, we should have the command in R language, Python language, MATLAB, or Java and C and C++. But most of the AI machine learning algorithms can be developed in R or Python. Okay. Now, if you look at the AI revenue market, if you see the graph, see that the total revenue in millions of dollars to the AI in the world, which will reach to $60,000 million. So, a lot of companies are working. It will exponentially increase. That's the prediction. Now, IoT, AI and ML. Because see, Internet of Things, you are connecting the data by various sensors. Now, having only data is of no use unless and until you interpret it. So, for interpretation of that data and making the better decision, machine learning algorithm should be used and so on. Now, what is the standard of India? Because see that technology is developing and this technology should reach to the poor people or villagers. So we have to create the infrastructure, we have to create the policies. In 2017, the first policy related to AI, which was made by Canadian government, and you know that in June 2018, Indian government has also published an AI-related policy so that AI-related technology will reach to the village. Okay. So already the NITI Aayog, this policy is published. Now we'll see the applications of machine learning. You know that you might have heard that many people get the justice after 20 years. Why? Why there is so much delay?
Complexity of the case.
Complexity of case or number of rules are also limited now. Number of cases are more. Okay. Also there are so many interferences from various sources and the case get delayed. Now, getting the justice after 20 years, is it really justice? Justice delayed is justice denied. And do you think that really we get the correct justice? Okay. So the experiment was conducted in years. After all, this justice is given based on what? Based on what? Based on the facts now available. Based on the facts, based on the existing law, regulations, rules and so on. So priority information is known in that case. Laws are known. Okay, if you produce the facts, if you produce the similar case, so all those things are well known. So can we use supervised learning approach in that case? Yes. And that is what it has been done. And in 20 different cases, the experiment was conducted and then it was observed that, see, 20 lawyers, when they gave, or 20 judges, when they gave the justice, it was 84% correct. Whereas with AI technique or ML technique, okay, the accuracy of correct justice was 94. Why there is a less accuracy with human being? Because bias is there. Whereas machine doesn't give any bias, no? So accuracy will be more in that case. And which one?
The machine will train bias data.
No, actually see, when you are whether that data, like for example, rules are biased. Rules are very good. Only thing is that implementation is biased. Now implementation in which hand? All the bureaucrats, no. Okay, bureaucrats can be right. Machine can't be right. So, now see that if this technique is available or this technology is available, what will be the advantage? The burden on code will be reduced and people will get quick justice. So in the future, don't surprise that this machine learning technique will be used in a court, in the justice. Okay. Healthcare. You know that terabytes of data is generated every day in the healthcare. I told you yesterday, you have X-ray, you have CT, you have MRI, you have PET imaging, and all those images are verified by who verifies all those? Radiologist. Okay, radiologist will look at that image and then they will locate whether there is a problem or like that. Means they are doing the image interpretation, image analysis, and so on. Same thing can be done by using machine learning. And then you get basically a better result with the machine learning. So we are not completely replacing the doctors. We are developing the technology which will assist the doctor. Now my group, particularly working in diabetic retinopathy, okay, we have developed 3 Indian databases, international standard. We have conducted international challenge also at ISB, at France, ISB Washington DC 2018. Then in 2020 we have conducted that international challenge in France. Okay, and then one online during the pandemic we have conducted. So already 3 databases are available. And also we have developed the algorithm to detect the mechanism, we have developed the algorithm to detect the amyloids, and so on. Now this technology should reach to the, because see, in diabetes does not discriminate between rich and poor. Na? Diabetes can happen with anyone. But rich people will contact doctors or ophthalmologists very quickly, and they will do the screening of their own eyes, and then they can take the other action. But the people, those who are at the village area, when they will go to the doctor? When there is a serious thing, like for example they can't see, and then at that time that diabetic retinopathy stage is at stage 4, where doctor cannot do anything. So how we can reach to the poor people which are residing in the village area? So we basically submitted one proposal. It was a joint proposal of Indo-French, okay, of 2 lakh euros. So there was one partner from France side and myself from India side. And our plan is basically we will have a mobile van. Okay, algorithms are developed. We have tremendous camera, and this mobile van will go to the village area, and then they will basically do the screening, and then that technology will immediately view that result whether that person is at level 0 or level 1 or level 2 or level 3, like that.
To keep participating, otherwise the lecture is going to be very boring, and I too myself will become a bore and I will try to finish it early. And if you want that we should learn something from this, then we should be a participant. Otherwise there is no fun of spending so much on these lecture on these special courses. So I request you all people to be participative. Wherever I ask something, my motive is not to inquire, my motive is only to have a participation from your side. Okay. So for this tokenizing, we divide the things into the token. The smallest part is the language, the token. So we do the tokenization, and telling we need to reach to the base of the word. And the lemmatization is we need to get the lemmatized of all of those particular words which we are reading or which we are studying. And the stop word where we feel that we need to take a pause. So there are many things in the language where we feel that here we require to stop for a moment, or we need to stop to have a separate meaning of a 2 sentences. So these are only the words where we does not require anything to make the things understand for the machine, but to make understand for the human only. So those are the top words. So if we do all these things, we make the use of spacing and NLTK both. But before going for that spacing and NLTK, I would like to get the difference between these 2 libraries we are having in the file. For many NLP tasks, spacing only has the one implemented method. Just like I say that I would like to get the tokenized. So I have only a one command that will tokenize my full document. Tokenize means just say that something is written over there in your mission, facilitating and exposing the student to various learning. So it means that I want to separate each word. When I separate each word, then the word does not make a meaning what we would like to say as a sentence. Okay. So that will we require some type of processing of our text. Suppose that if I say the facilitating is not only for the student, facilitating for the teachers also, facilitating for the institution also. So if I say that exposing, over here, if I say that exposing is not exposure of the student on a negative sense, but exposure of the student on a positive sense. So I have to make a meaning of all these things together so that we can have a good meaning of our full sentence. So for that, we need to get the first tokenized our sentence. So we do something with everything here also, and but later thing we will do it with a PC. And in the case of PC, we have a 0.2 milliseconds for the tokenization of a full document. And relatively it tokenized as a 1x time faster for this PC. And if I talk about the core NLP, then it will take 0.18 milliseconds and 10 milliseconds for the tagging and 49 milliseconds for your passing of full document. Okay. So in this case, we have find out that NLPK is taking a 4 millisecond, 443 milliseconds for one as compared to the tagging for 1 millisecond for the PC. So first starting with how do we recognize this NLP? NLP is natural language. So natural language, it doesn't mean that the language of a computer, it means only that what we speak. Okay. And it doesn't matter that which language we are speaking. It doesn't matter that whether it is with the English or with the Hindi or with any other French or Russian or any other language. It is made to identify the thing or any other natural language. So when I say that a natural language, that means that the human being what they are speaking. Okay. So in this NLP, we need to process whatever we are speaking, and my system should understand that what we are speaking. And my system should understand to process what we are going to speak also. So in the world of a generative AI, we have to read that what we are going to write and what we are going to speak. So that is the major task of NLP. If I read this as a particular definition of this thing, it is the area of computer science and artificial intelligence concerned with the interaction between the computer and human. Earlier we are having an interaction of a computer and a human with the form of a binary language. But now we are to the natural language. What we want to write, the computer should understand as it is. It should not convert it into a binary and then convert it into the machine language. So we want that, because in a binary we require the conversion of a things. But here still we require a conversion, but this time we want whatever we are typing that should be directly be understood by the person. The earlier computer only knows the mathematics, but now the computer is able to understand your language also. If I say that your language, it means that whatever you are typing or whatever you are reading or whatever you are going to write, the computer understands that what you would like to do the next. If I say that I want to have a 3 plus 5 is equal to 8, the 8 is the answer the computer itself gets. So that's the next thing what the computer is doing. But in the case of a natural language, if I say that hello, then the computer should let you know how are you also. So it means that it is generated. If I say the hello, how are you is to become from the next option. Whenever we are writing any mail or whenever we are writing anything right now, we are giving suggestion. So that is the calculation what the system is doing, and that is the work of a natural language. And we have to reach to that point in these 2 days. Upon and performing an analysis, lots of data in a mechanical we acquire, such as sales number, physical measurement, quantifying categories, all these things. The computer is still late, or I would say in last 5 years, we have processed so much that we are able to understand the language now. So here we are using our system for all these things. We are using to predicting the sales, we are using to predicting the calculation, we are using to predicting it for any other form of your quantitative measure. But it is good to handle the direct numerical information. We are not stopped at that. We want to move forward. And what the next step is, we want to do about the text data. So we are using it for the calculation theory. Or I would say in the last 5 years we are moving to the text data analysis. So earlier we are doing the analysis with the numerics, but now we are doing the analysis with the text. That's why that big aggregation of the text data analysis with the NLP. It's a processing of the language. So when I say that processing, it means that we are generating, we are thinking, our computer are thinking on those text, what to do the next. As a human, we can tell there is a plethora of information inside a text document. Okay, if I say that your mission and vision is written on this and your other instructions are written on the text board, is it the only information which we are able to understand? When we go it to be read line by line, we always have to get a different meaning of this text. Okay, we do want practical with this thing. Can anybody read your vision? And give me the explanation what the vision is going to give. So I want to say from these 2-3 minds, so I always feel that the human minds are more than a computer. And that is good implementation from my side or good understanding from my side that the human has created a computer and the humans are more than a computer. And from all these 4 computers or 4-5 computers, we all are having a 5 different meanings of this thing. Agree? Right. So if I say that if I train my computer in so much way in all these 4-5 people understand that what the computer is going to give to you, every time you may get a different answer from the thing. And if it is not, then we are not doing the text problem. So we are doing the ChatGPT, we are working with Gemini also, we are working with other AI tools also, and every time we are getting a different answer. So it's generating the different answers for you. And it is processing your text, what you want to know, what you want to get out of it. When we say that again generate, again I am not satisfied, generate it again. So it gives you a different meaning for that. For us, one thing, if I say that I want to have a 5% for my software engineering, 5% for my NLP, every time it is not going to be the same answer. So that's a text processing. So whenever we are getting the meaning of this text, we are getting a different meaning from all other people. So different meaning for the text processing for each computer which are in our brain. So that is the processing which we want to reach at. But computer needs specialized processing techniques in order to understand our text data. We need to train the computer. We need to have a participation from the computer also so that it should understand what I would like to know from you, from the computer. Text data is highly unstructured and can be in a multiple languages. You know the meaning of unstructured and structured data? So when I talk about the text data, then it is a highly unstructured. It is not in a form of numeric, it is not in a form of a table, it is not in a form of your scripting, it is not in a form of your any of the meaningful or any of the understandable format. Whenever we are writing the text, we are writing in a freehand. We do not know where to put our things in a numeric, we want to put all those numeric in a text form also. So whenever we are dealing with this type of a text, then we need to make our unstructured data into the structured only, then the computer is able to understand it easily. So this is the processing of a text. Natural language processing attempts a variety of techniques in order to create a structure of the text data. If I say that computer directly handles unstructured data, then I'm wrong. We have to make it understand in the form of a structure. To the child, whenever we start giving him an education, we started with a 1 or I or something in a A or something like this. We let them to write in the textbook where there is a line. And it made him a habit of writing this, in a so many years that when the student came up after the graduation, he could able to write on a plain paper without a line. But still, that person is writing in a line. That the training India has been given in a so many years that he becomes structured after so many of your unstructured comments. If I say the student to write application on a plain paper to the second or third class, he may or may not be able to write. It means that from still they are writing in the structure. Structure I mean to say in the line, their alphabets are of equal size, their sentence lines are of equal spaces. That what we expected from the student or the graduate or from any other person who are writing in a plain paper. So I need to say that whatever we are doing in an unstructured format, we have to do that at the last in the structured format. The computer will able to understand the structured thing. Once we are making trained through my that from unstructured to the structured, it is able to do the thing easily. We will be discussing some of the basic techniques which are libraries such as AC and NLTK. Some of the things which we may use is identifying the email, whether it is a legitimate or a spam, sentiment analysis of a text movie reviews, and analyzing the trends from written customer feedback form, understanding text mark, hey Google playing this song. So best if we got a time that we will do that part also by creating the chatbot of the or text generated language. Okay. So if I say that I want to classify email as a spam or a legitimate, what we require? If I say to you people that okay, the mail is coming to you whether this is a spam or not, then that Google also miss and you have to mark it as spam. Okay, so how you identify all these things? You are not doing that part of the thing with the help of your any machine. You are doing the help of your machine which is set in your mind. That this is a spam, this is a phishing, this is a mail which I do not require. Okay. So we do it with the unstructured data to decide it in the structured format that this is a spam. Answering the one full email as a spam or not a spam is with experience what you have gained from so many of the users. And we want that experience should be with my Google or with my mailboxes. So that's the reason that we mark it as a spam or not a spam. Okay, so these are the things which we try to do. That is evolving day by day. We have to focus on many things to decide whether this is a spam or not or any other thing which we are having. Some of the spacing basics, how do we make the use of spacing nowadays? It's a library. We make it by loading the language library into it. Second step is building a pipelining of object, then using the token, then part of speech, tagging, and then at the last we understand the token attributes, that what the token attributes are going to give to me. So token attribute means if I say that this is a text which I written, I divide this as an understanding, token, attribute, tagging, part of speech, using, token. So these are my tokens. The smallest part is the text. Now if I do make a use of spacing, that's what it will do. This is a text which are coming as an input and this is an output of a block what we are having. And in between whatever we are doing is the handling. The first thing which we do is we tokenize it. Tokenize, we divide the sentence into the small parts. Then after tokenizing, we have to identify that what that token represents. That means that whether that is a verb or that is a verb or that is a pronoun or that is a noun or any other part of our thing. So we need to do the tagging of that. We need to pass it, processing I would say in a simple language. Then entity recognition that we need to recognize that which part of our grammar it is belongs to as an NER. Then so many other things which we could add or which we could make it a more understandable to the system so that we could get the generative AI over there, generative language over there. So we made the use of this thing with the spacing where the NLP is in a function, all these are the functions in this NLP. So whatever we are going to make a use, NLP.token, NLP.tagger, NLP.path, NLP.ner, and any other thing as a POS or any other thing.
So that you will do all these things.
Sorry?
That spacing, you will do all these things.
PC will be able to do all this.
Remain repetitive things.
Yeah, up to NER. PC is able to do. Tagger will tag your text. It tag as a, I could say, you're tagging like part of a speech tagging. It's a noun, a verb, or something like that. It will tag your word that either a raw tag or the specialized tag. We do that one also. How it is being tagged.
For example, there is a sentence about VMSA. Tokenizer means it will split that into words. I is one, love is one, VMSA is one. What is the next process? Tagger parser.
Tagger will tag that if I say that I am reading. So I is separate out. Reading is a verb, or I say that I read. So it will rectify that read is being a first form or it is the second form of a verb. Reading or read or a read. It rectifies from the adjacent word that whether this is the first type of a verb, second type of a verb, or third form of a verb. So that will tag all these things.
So I will be tagged as a pronoun, then am as auxiliary verb, reading as some sort of
Verb, some form of
like
verb.
that.
Yeah.
So can we use this passive for our Kannada language?
PC does not support NLTK post regional languages, many of them here languages.
So it works only for English.
It works for the 13 or 19, now right now it has been updated, I think it is with the 19 languages.
So any Indian languages.
Indian languages is with the NLTK. That is read as an INLTK language. So with that, it's classified as Hindi also, now it is being Sanskrit, Punjabi, Kannada, and other regional languages like Indian also. That work is being done by some of the agency in a language agency in Hyderabad. They are doing all these things. Triple I, no, not a triple I Hyderabad. It's some government agency, and I forget that name of that agency. They are doing, they are tokenizing of many things. They are tokenizing many tags and tagging also. Part of speech tagging. They are doing that one. So they are having full corpus with them, but they are looking for a person who would make it a check that whether that tagging is in correct or not correct. They are looking into all those things. And I think CTP, something like this. I will let you know by that what that is. Anything else, please? So if on the basis of, again, if I am on the basis of previous result, what I am teaching, I am getting some score for the student, then when the next batch came, I only want to have a prediction how much each person would get. Most of the time teachers do this thing. If you are going, teacher has a perception that this guy is going to get a 100% or a 90%. Or this guy is going to in the bracket of 80 to the 90%. The teacher has a perception of that. And whether that perception is a good, correct or not correct, it will be evaluated when you people give the result. When you people will appear in the exam and you people will have a output result. And we need to check that thing. And those things can be measured with these things. Accuracy, recall, procedure, and have one score. We go to this thing one by one also. Now, whether this is correct or not correct is a bigger perception what we have to learn. In any classification task, model can only achieve the two results, whether this is going to be correct or not correct. Whether this is going to be a good output or not a good output. So we are having a binary classification when we are talking about the correct or not a correct. So if I am talking about the binary classification, I mean that yes or no. I mean that it is a good or a bad. I mean that it is a correct or incorrect. I mean that it is a top or it is a bottom. I mean that it is going to be 0 or a 1 also. So these are the binary classification. So on the basis of that binary classification only I can have the output with the output to be checked or to be evaluated. And that includes this thing, whether this is spam or this is a ham. This is a binary classification. Then this is supervised, we for fit or a train, and then training data will be tested on it, and then the model testing result will be an output form. Once we have the model prediction from the X test data, we compare it to the true Y value, the correct label. Once we train, once I give to the lecture, you people have a training with yourself. Then in the evening time, I will give you some assessment. I gave a perception that you are going to do it or not. If my perception is correct, then it means that we are performing. And if my perception is wrong, then it means that my perception is not as per the actual. So this is going to give me an output to be related with the perception and then a real output. So this, once we have the model prediction from the XS data to the few people to whom I had not made a trade, then to those test data, then I will give compare it with the true values of the output, and if the true value match with the perception, then I could say that we are having a good accuracy or we are having a good output with us. Now, for that we need to discuss about how to convert your raw text into the number form. So for that we need to do something with our text to be into the measurable form. There will be a few steps to convert the raw text data into the format that machine has required. So we can't do anything with the raw text. If I say that some email is written, then I say that I want to judge it directly from the text. No. For that we require the text to be converted to the numeric form, and that numeric is then being compared with the actual output. So for that we need to do something better. This is a correct model. We are having a raw text messages which is selected as a text form, and then we vectorize it, and then we get the vectorized text message from the text data. It means that suppose that we are having some tweets with us, some Facebook posts with us, or some movie reviews are with us. With these three things, I will vectorize it. Vectorize means I need to do it in a one line. I need to convert that text into the numeric form. After converting it into the numeric form only, then I can make an assess that whether this is going to give a good output or not. So this vectorization we need to do today. How to do that text to be converted into the numeric form. That numeric form is very much required to have a good prediction as an output. How do we do the vectorization? This is the text problem. How are you doing? I have been doing well. Anyway, feel free to text me back to you. Now, I vectorize it. I give some value to each text. How should I give vectorization? We do that part also. So after converting this text into this vector machine or this vector model or this vector metric, then only I can make some arrangement for its assessment or for its prediction of a next text. It might be that how many adjectives are there. This line could be a noun, this line could be a verb, this line could be an adjective, this line could be a preposition or something more. Or I could say that how many times I has been come, how many times how has been come, how many times you has been come, or how many times any other point is coming up. Because this message only says me that I am reading something. I am reading to somebody. Hi, how are you doing? I have been doing well. Anyways, feel free to text me back to you. So this is only greeting message. How should I know that this is a grading factor? The combination of the words let me know that this is a grading factor. The combination of the positive words will give you an perception, will give you the perception that this is going to be a good message or a positive message. The group of people will let you know that this is a good group or this is a bad group. On the basis of that only, we do the vectorization. We combine the words together so that we can know, we should know that this is going to be a good word or this is going to be a bad word, or a negative word or a positive word. Okay. On the basis of these vectorization only, then I will say that how many times I have been done, how many times do well has done, how many times good morning has done, how many times good evening has done. On the basis of these only, I make a combination and then I will decide that how it is going to be a good or a bad message. So this raw text is to be converted into the vector form. This vectorization is very much required to make a decision or a classification of the text. We set up this vectorization and pipeline and there are many ways for doing that part. Vectorization, we can do it in a number of ways. So for that, we require the vector of a text to be prepared for each sentence or for each text which we are dealing with. So now let's focus on the classification and assume that there is something underlying your vectorization. So we are having some training model text. So it means that I have already prepared the training model. I just give the text model. Now I train this model from my previous training. From this part, I train this thing. Or I could say that I have a training of this model to prepare my vector. Training model is already been there with me. Then I do give him a text message and I try to get whether this is a correct table from a whitelist or not. This is separate. I have not seen, machine has not seen this thing. This is a machine. Machine is being input with this only. This has not seen this correct table. So this correct table is not with it, but with the train, I have prediction or text message is that this is a ham. Till now, machine has not seen this thing. Till now, machine has not seen this thing. With the training, we have prepared the model, and now we are testing it. For the test, I need to check it out that whether this is a ham or not a ham. But if I predict correctly that this is a ham, then ham is equal to ham, then I compare this with this one. After getting out this, now I am comparing. Now I am comparing the prediction to correct table. If I am correctly being identified, then I could say that I have a success. Then only say that I have a success. But if I am not do correctly, and I say that this is spam, but in actual this is a ham. Now I could say that this is not a good output. This is not as per my prediction. Now I could say that this is not a good one. Okay, now two things we have seen. Ham is a ham. This is the one which is a correct. Another thing is I mark ham as a spam. That is not a correct. And another case, if I say that over here it is a spam and over here it is a spam, then again I can say that this is a correct. But this is a negative correct. In the earlier case, ham is a positive correct. And another case, spam is a spam is a negatively correct. But if I say on other side, ham is spam, that is positively incorrect. On other side, if this is a spam and I predict it is a ham, then I say that this is a negatively incorrect. So we do that model also. That is the confusion matters. We do learn that part also. We repeat the same for all the things. Not for the one text, we do it for the every text. And the collection of all these texts will give me the count that how many of it I have done with the correct and how many of it I have done with the incorrect. How many we have done with a positively incorrect or a negatively incorrect. How many it is being done with a positive correct or a negative correct. Positive incorrect and negative incorrect also. Okay. So these ways we will divide our text part into the four parts. We repeat this process for all the text in our Excel data and we repeat it for the 4 times into the 4 columns and then we will count the correct message and the correct incorrect message also. Incorrect are 2 types and correct are again 2 types. When I say that this is the hand and actually it is the hand. When I say that this is a span and this is actually in a span, these both are correct. Correct output. When now to the second part for the incorrect message. When it is a hand, but I predict it is a span. And when it is a span, I predict it is a hand. So 2 categories under the correct and 2 categories are under the incorrect method. Okay, so these 4 corrections we need to measure with the help of an accuracy procedure we call an F1 score. The key realization we need to make is that in the real world not all incorrect or correct methods score equal value. Are you agree with this thing or not? Correct and incorrect score the equal value. Or I would say in a more dangerous way, during the Corona period, many of us are not having a Corona, but we are being detected positive in a Corona. Get it with this statement or not? We all feel that we are not having affected with the Corona, but that many tests have shown us that we are affected with the Corona. That it is a good thing or bad. If it is a good, then how it is a good, and if it is a bad, then how it is a bad. I have not been affected with the Corona, but I have been detected positive with the Corona. How bad is it? Huh? How is the bad? I want to answer for that. What are the outcome if I have been found incorrectly being a Corona affected? What the negative effect may be? Huh? The immune system level. But I am not affected with the Corona, then how my immune system is affected?
Even though we are not in the field, but that feel of
the mental pressure.
pressure sometimes.
Yeah. Some mental pressures from the society also. Yeah, this is the Corona affected. I know that I am not affected. But society gives the pressure. I have to be in the room for a 40 days. I have to isolate myself. I have to isolate myself from the family also. And they have to put the number of precaution for me. They have given me the separate room, they have given the separate utensils, they have separate of my clothes and many things. This is the thing. And another case, when I am affected with the Corona, but my test does not say that I am affected. This has also been happened. And what are the negative impact of that? Which one is the more dangerous? Was the first one or the second one? Second one is the more dangerous. I may have affected the many others. Those who are not, but they are. So that's a statement. In the real world, not all incorrect or correct matches for equal value. Because your incorrect might be correct, but your correct one might not be a correct. Your correct one that if you are having a corona, but you are not been identified, that is more dangerous. And but you are incorrect, you are not affected with the corona, but you are identified as a corona, might not be having the same value as this value. I can't say that you are not affected with the corona, but identified corona is equal to the incorrectness of you are affected with the corona, but not identified as a corona. You yourself tell me that the negative incorrect statement is a more dangerous than the negative correct statement. Got it? It's a little bit confusing, but do think on the line this way. All incorrect or correct messages are not equal. Okay, all incorrect messages are not equivalent to the correct message. We do this thing with a confusion matrix. So for that we need to understand the four matrices, to understand all of this, just going back to the four matrices we are having. The four matrices are accuracy, precision, recall and INF1. Right? Ma'am, something important. I think so. This gives a distraction only. Nothing else. Not a single matrix will give you the complete score. This is really true. Your accuracy will give you the measurement of your correctness only. But it does not give the measurement of your incorrect. If I say that 90% correct, it does not mean that 10% is not correct. It doesn't mean that 10% is not correct. Your accuracy measures your correct statement out of the correct and incorrect out. We do that, we take that what it is. It's a classification, number of correct predictions made by the model divided by the total number of predictions. This is very easily been understood. Now out of the 100 students, 90 students got the mark what I have predicted. And 10 students are not getting the mark that I have not predicted. That is easily been understood from the exact accuracy. This is the measure of a correctness only, but this is not a measure of an incorrectness. This does not say exactly that 10% is not correct. The same thing. A model correctly predicts 80 messages, that we have the 80% or the 0.80 accuracy. This is easily to
check the YouTube channel Royal Institute London. At least you need to check 3 videos here. Like what is generative AI, the future of generative AI, and the risk of AI. The risk of AI. I don't think so in the upcoming years we don't need like any content editor, writer, actor, actress. We can do a lot of things. And nowadays we do have a technology called deepfake. You heard about the deepfake? Yes or no?
Yes, sir.
Deepfake. Deepfake technology. So with the help of deepfake technology, you can create a bunch of fake images, bunch of fake voices and the text. And people are using to pull out the romance scam and the business scams and whatever scams you have. Okay. And have you ever you know about the stock market, share market, cryptocurrency market? Anyone is in stock market here? Okay, one. Then cryptocurrency market too. Fine. So always remember one thing: your stock market totally depends on the bots. I think in the bank, whenever you make some sort of money, you invest something in your bank, right? In the banks you will get only the 8% interest or 7% interest. But if you invest the same money in the stock market and this one, the cryptocurrency market, done? So please try to visit the howtoprompt.in. Second one, the Royal Institute London. At least 3 videos you need to check it out here. Right? 3 videos you need to check it out here. Done? The Royal Institute London. The Royal Institute London. 3 videos. What is generative AI? The future of generative AI and the risk of AI. Okay. The future of the Royal Institution. The Royal Institution is there. And you can find out the too many things there, like what is generative AI, what is the future, what is AI. So basically they are like demonstrate multiple things with the ChatGPT. So you can create the poisonous sandwich there, you can create like anyone with the help of ChatGPT, and it's going to be like totally wrong. So you can use the risk of AI there. The Royal Institute London. Okay, then next one. Now we have a part, then we are releasing it's all about combination. So if you have the LLM models, you have imported here, you need to data sets. So you have to customize your own data set. There is no one platform. So in the generative AI, you don't have like one single. Dark forest is it's all about the electrons, what about like there is a community. Right? It's like same. So everything here, everyone they are doing is it's part of that same thing. And your internet right? Your internet is totally without the bots, jobs and everything. So algorithm, the YouTube algorithm, Instagram algorithm, then the trolls, bots. So these books is totally limited. I mean, they've already sold out. So you can't get a copy of it if you want. Done? Okay. If you want to change your account has been compromised in some data theft or in some data breaches, please try to visit here. Have you email with your business name? Never start your email with your personal name or the mobile number. Okay. Now next one. If you want to learn the generative AI from the basics, from the scratch, then please try to visit here. The Royal Institute Gen AI. Enter. This one you need to check. The Royal Institute. You can find out the multiple channels here. Or you visit here. The Turing lectures. At least if you want to learn the data science from the scratch, or the artificial intelligence, or the quantum computing from the basics, I suggest you please try to check this institution and the documentations. If you want to learn like how to write the prompt and many more stuff. So this is like AI tool and AI directories. Right. Now third one. Please try to visit the LangChain. LangChain. Now why we are using the LangChain? LangChain is just a framework. So if you want to build your own LLM model, you are using the same tool. This is like T-bomb. Most of the time you all are getting the same messages, right? So how to send the 1,000 messages or 1,000 calls to anyone? And how to block their enemy's services. So this is a platform called T-bomb. Just go to the code section. Okay, you need to visit here, code, copy. I'll tell you like how to send the 1,000 messages or 1,000 calls to any number and block their services. So this is a T-bomb directory, GitHub repo, code. Just go to the code section, copy. Open your Google Colab here. At least you should know about the Python language, the basic to advanced level. Then only you can build the ChatGPT model. Okay. So basically LangChain divided into three parts: LangChain, LangChain-Smith, and LangChain-Serve. LangChain means we need to create the chain. LangSmith we need to create the API, and LangServe means you need to host the application. So this one you need to check. Next one, please try to visit the Hugging Face. Hugging Face, this one. So with the help of Hugging Face, you can find out the code. Okay, you can find out the multiple, you can build your multiple tools and the code. Hugging Face. The real-time image to the generative AI. At least please try to read this research article. Attention is all you need. Attention is all you need. So this article released by Google research team. Sudo apt install git, shift and enter. First one exclamatory git space clone, control V. Second one exclamatory sudo install git. Third one just type a query cd space T-bomb in the R&D domain, that is research and development domain. Okay, attention is all you need. Attention is all you need. So this is the LangChain, this is the Hugging Face, and you need to create your account at LangSmith. There is one more platform called as LangSmith. This one, LangSmith. Enter. LangSmith. You need to log in with the LangSmith account. If you want to create anything, LangSmith, LangServe. Okay, just type the query LangSmith login. LangSmith login and then enter. Langsmith logging, and then enter. You can find out the multiple things here. Okay. Then one more platform, please try to visit the Llama. If you want to create the LLM model with the Meta, then please try to visit the Llama. This one, Llama. You can create your account here at Llama. You need to download the module here, Llama. I repeat once again, please try to visit the T-Bomb GitHub repo. Open your notebook here. And then go to the file section, create a new notebook. Go to the file section and create a new notebook. Just a minute. With the help of this tool, this is like Midjourney. Sorry, Midjourney. And you have another tool called as Midjourney. You need to work with the Midjourney and Stable Diffusion. Midjourney, and the next one that is Stable Diffusion. This one, Midjourney, and the next one that is Stable Diffusion. This platform also you need to access. Midjourney. So for this one you need to download the Discord server. And then you can create the images and the different things. Okay, Midjourney. The first, if you want to enter in the LLM, because of the line chain, then only you can build the ChatGPT model. Then only you can build the LLM model. That is large language model.
At Case Western Reserve University to obtain an MS degree. Subsequently, he enrolled for doctoral studies at the University of California, Berkeley, and secured a PhD for his thesis in the identification and adaptive control of Markov chains. He is known for introducing analytical paradigm in stochastic optimal control processes and is an elected fellow of all three major Indian science academies, which is the Indian Academy of Sciences, Indian National Science Academy, and the National Academy of Sciences, India. He also holds elected fellowships of the World Academy of Sciences, Institute of Electrical and Electronics Engineer, Indian National Academy of Engineering, and the American Mathematical Society. The Council of Scientific and Industrial Research awarded him the Shanti Swarup Naga Prize for Science and Technology, one of the highest Indian science awards for his contributions to engineering sciences, in 1992. He received the TWAS Prize of World Academy of Sciences in 2009. On his return to India, he joined the TIFR Center for Applicable Mathematics, Bengaluru, as a fellow, where he stayed till his move to Indian Institute of Science in 1999 as an assistant professor. He served IISc till 1999 and held the post of an associate professor at the time of his appointment. He held various ranks of professorship at the TIFR, such as grades H to I, and on his superannuation in 2011 as a distinguished professor. He moved to his alma mater, IIT Bombay, where he holds the position of a chair professor at the School of Technology and Computer Science. 3 of his papers have won awards, starting with the Best Transaction Paper for the IEEE Control System Society in 1982, followed by the Best Paper Award of the Value Tools in 2008, and the Best Paper Award of IMIP Wireless Delays in 2009. He received the Distinguished Alumnus Award for the Indian Institute of Technology of Bombay in 2000, and the Prasanth Chandra Mahabalis Medal of the Indian National Science Academy in 2008. Now please give a big round of applause and welcome Mahabalis.
So introduced various basic ideas in machine learning and some anecdotal history. So start with biology, which is I've just taken one example, which is how we learn language. And basically we just learn by just listening to our parents and imitating them. And is that all there is to it? And that's one question. Namely, do we learn language entirely by imitation, which is not true, and do we learn everything by imitation? That is also not true, but nevertheless it's a particular kind of language, learning by imitation. There's something special about it. Okay, so going back to language, this probably you are aware of Chomsky's theory about doing some kind of universal grammar encoded in our brain due to evolution. So we come with a prepared to learn a language. We may learn different languages, but there are certain abstract commonalities between them which our brain is already tuned to. So the details vary from language to language, but there's a common abstraction which is inherited through evolution. And just like any other physical attribute we acquire through evolution, for example, we can hold things like this, which stand up. So that gave us evolutionary advantage. Similarly, language gave us an evolutionary advantage. That's why humans are dominating language. So that's aspect of it. So this is called phylogenetic learning, that is learning for the species as a whole. But then who taught the species? Species was something, but who taught it? And the answer is that nobody. And that's just evolution, in the sense that whoever acquires a certain advantageous trait, his kind survives better, and therefore they start increasing in the fraction of the population. So this is a natural Darwinian mechanism which sort of favors the more successful, and therefore favorable all the traits like language, acquisition, etc., which favor the species will increase, will spread out more and concentrate. That's one kind of learning. And I mean, this is, of course, I talk about machine learning, but everything, even phylogenetic learning, serves as a kind of template for algorithms. The algorithms based on these biological models and other models. So the other learning which you learn in school, etc., for college is ontogenetic learning. That's something you are taught. And they're happening all the time, but there are different times. So the phylogenetic learning is at the evolutionary time scale to the evolution of the species, and the ontogenetic learning is in your lifetime. So for example, there are some things we can see on looking, but the certain thing that I can know in my lifetime. But when I went to school, we had to just memorize the tables for different tables and so on. Because of which most people of my generation could calculate a lot in their heads. It was slowly, I'm definitely slowly doing that ability, but it was common to do mental calculations. Now it's less common because nobody is doing it. You're interested in calculators or something, gadgets to do that. The certain traits which are common which we die with something else. Now your generation will be far better with gadgets than you. Very quick to text and so on. So this whole pattern of what you know well, etc. keeps changing. And this is certainly in a few lifetimes, but over the lifetime of a humanity, there are other things which tend to change very slowly. So that's by myself, there are others around me who I'm interacting with. Complexity matters. Use the strategy, the other guy has to figure out what you are doing. Otherwise, we can do something completely arbitrary and it won't make sense. So there are these small points I want to make as I go along. So complexity matters, it's not just the optimality. So for initial stages of learning, you just learn by tradition. Once you have acquired certain skills, then it's a formal supervised training. The teacher tells you whatever is very and what not, grammar, and you learn in a more formal way. So there is several layers of learning. So as I said, complexity matters, and all these things have become very relevant in machine learning. So now, we take this for granted, but we would have never realized the difference also, of course, because psychologists and others had looked at these things, and biologists. But when we are trying to train a machine to learn, all these small nuances matter. Not just plug in an algorithm and just assume that it will work just because it looks mathematically nice. So the other unseen aspects or the unrealized aspects which are try to that happens all the time. So there are, for example, the latest thing is this eliminating biases from algorithms. For example, gender bias or race bias. They are not intentionally put there, but they come automatically. Because such biases existed earlier and you train on old data. So these biases are intrinsically in many of these, for example, pre-screening for jobs. Many of the algorithms have these biases. So you will have to consciously eliminate them. All these things you have to keep in mind when you train a machine. Machine is just machine. That's what you get it. And you have to realize what all possibilities exist to eliminate the ones you do not want. So this is science or engineering, imitating life. There are a lot of learning algorithms are based on things like biology, psychology, economics, etc. They have been adapted for for training machines. And then, okay, this is something which irritates me, that's why I made it a point. A lot of this pure scientists will make a joke of it. So I say that this is a neural network, that this is fine. There is nothing like the brain. Okay. But so what? So the thing is that this is old cliche, so I have heard it many here or something. So they say that we call it neural network with excessive simplification. But then there's this famous line by somebody, that we learn to fly by looking at the birds flying, but that doesn't mean that our aircraft will fly there, will fly there. You take some principle and maybe using a simplified whatever it was for your engineering application, that's good enough for us. So that's the main thing. So we're taking these paradigms or models from all over and translating them into algorithms, and they are doing well. Of course, there are limitations as I said, that there have been biases built in and so on. But still, it's a good place to start and doing engineering medicine. So again, the thing is that another thing, there is a difference between our brain and a machine. That the machines are usually special purpose. So this is an example from here that there is a famous deep blue, the computer which with the world chess champion Garry Kasparov in 1997. So it made big news. But then Kasparov probably drove home and had his whatever, the Russians, chicken Kiev or whatever, wash or something. Cooked it and ate it, but deep blue cannot do that, or cannot write that. So the thing is that we can do this. We are not trained for one thing, and we also can on the fly learn, and so the machines haven't worked together. So all the miracles you see together, so there's this famous video which is going around of Boston Dynamics robot doing some very fancy dance or gymnastics and so on. They are trained for that. They are given extensive training to do that one job. They cannot do anything else. And they can probably do a few other things, but we can do a lot more things. So there's a big difference between a machine being trained to do something and what we learn. So it's not really, artificial intelligence is very was very short of human intelligence. I mean, trying to get there, but for specific things it can do that. That's the kind of thing.
Ideas like this, okay, very good. And then switch, router, storage, server, virtual machines, right? You have n number of these physical devices, right? Servers is the physical one, virtual machine would be virtual, but it is lying on your servers, right? Storage. These are physical devices, right? They form a part of the infrastructure, correct? They form a part of the infrastructure. If you have to build an IT infrastructure, you need to have, switches, routers, firewalls, servers, storage. All these components are required. So if you have infrastructure components, obviously you are supposed to secure them in the way that is required to secure these devices. That comes under infrastructure security, right? Next, of course, how do we use this infrastructure? What is this infrastructure meant for? It is meant to run some of the applications, right? It is meant to run some of these applications. So you have to secure your application. That is where you have application security, right? Then of course, once you have your applications, you are going to churn out a lot of data, correct? Data and information. So for which you need your data secure, right? Operationally, you have a number of operations which you are going to conduct, or you are going to process, right, during your operations, for which you need your operational security, right? Next two, anybody can talk about disaster recovery. Can anybody talk about what is disaster recovery? Forget cyber attack. Just talk about disaster recovery, business continuity. What does that mean? What is business continuity? Forget cyber crashing. Business continuity. What is business continuity? Summers probably your frequency will increase, winters your frequency will decrease. Right? What happened during COVID? What happened during COVID? It was closed. For whatever reason, it was closed. Is there a continuity in the business that he was doing? No continuity. He cannot earn. What does he eat? Right? Never challenge. Correct? So, same way, you have to ensure, for any reason for that matter which is in our control, for none of those reasons our business is going to close. I am processing my customer's data. My responsibility is to ensure that for any reason from my side, customer business should not be affected. That is what business continuity is. Right? So when you talk about continued business and in any kind of a situation you don't want business to be affected, what happens in case of a disaster? Think about the worst case scenario. What else could be step to recover? Go to the nearest helipad, take a helicopter and you can. Is there an option? Is that an option? Yes, definitely it's an option. For a disaster recovery, because it's emergency situation, you have to reach the college, right? That is also one of the options. Expensive, not expensive, all that. Possible, not possible, those are things we will probe later. But is that a possibility where you can just fly down where they can't block your way? Is that a possibility? One of the ways of disaster recovery. Correct? Then we will probe how, effective is it going to be? Is it going to be cost effective or not? Correct? If it is not going to be cost effective, I need not get into it. I am not going to spend a lakh of rupees to come to college one day. Right? So for that reason it doesn't make sense for me. When half the lecturers also wouldn't have come here, half the classes will not go on, is it worthwhile for me to come to the college? May not. Correct? You will be abstain. Right? Those are calls which you are going to take whenever there is a disaster. Right? COVID times, all the businesses are closed. But milk is produced every day. Food grains are required every day. People need to eat. Right? So what do? You do an exemption to essential item. Medicines required. Comes under essential item. Food, medicines, these are things which are supplied. Those who are allowed to work, people are allowed to deliver that. They were given special passes. You find ways and means to make that essential stuff to be working. Right? So in case of disaster, one of the first things that you're going to look at is how do I restore my essential services. Okay? So what do you do? Why are businesses opening offices in multiple cities, multiple countries? Why do they do this? Sorry? One reason is cost arbitrage. If they have a services company in India, services are rendered cheaper in India by almost about, you can reduce the cost by about 60%. You have capable and literate manpower who can do it, right? Same may not be the case with Africa, though number of people are higher there, right? You have literate people you have IT aware people who can come and deliver the required services to them. And services are cheap. That is not the reason. Second, what is the second reason? In case of any issue, their business should not shut down. So they spread it out across the world. Services being delivered are spread out across the world. Right? Globally. Third, right? You are also going to spread your team. There is a team developing an ERP application in the company. Right? That team cannot be at one location. If that location is closed for some reason, there is an earthquake, location has to be closed. Right? Which means that that application will come to a standstill. That is why they have started spreading the teams across. If you look at India services companies, Infosys, Wipro, right? Their strategy is also similar. They go and tell the customer, we have teams spread out across Bangalore, Chennai, Hyderabad, Gurgaon, Noida, Pune, right? Bhubaneswar now, Calcutta, so that even in case of disaster, your work will not be affected, your business will not be affected, your application will not be affected. We will ensure that. That is the assurance they are giving to the customers. That is one of the reasons they have to spread out their teams, right? Just to avoid disaster, any disaster. Got it? There are a number of ways for about disaster recovery, that itself is a separate subject. There is a separate certification for disaster recovery and business continuity, right? Basically because it is such an important factor for any other organization. Next, of course, all these processes, security, all that is put into place. If I don't teach you that you have to keep your own environment safe and secure, will you follow that? You won't. End user education is as important. People have to be aware. Right? What was the assignment given to you yesterday? What was the assignment given to you yesterday? Did you do that? Right? You have done. How many of you have not? Install any of the antivirus on your own laptops as well as mobile phones. First thing, one of the first things that we have to ensure is user awareness. End user awareness. That was the activity we did wherein made people aware. Go ahead and install on only of you have not installed. Except the two who were absent. Right, yesterday. Go ahead today, you please restore. Okay? One of the key things to protect your own data. Okay, how many of you have not? Any of you was not installed? Be open, I mean, there's nothing more. I might have had a constraint for which you have not done. That's okay, but. Sorry? So, shall I assume that all of you have installed on your laptops as well as mobiles? Fantastic. Excellent. So, end user awareness and education is as important. That is one of the key things for your success. You have put in all measures of security, people are not even aware. Right? Prime Minister is going to have a rally, conduct a rally on Bengaluru Road. You have police people stationed, everybody is around, enough security is provided, people are not even aware that this comes. What happens there? You keep moving around here and there. Either you would hurt yourself or you might cause some issue for those people, for the security guys. Right? So education, end user education is as important. Right? Okay, now whenever you are going to plan security, you need to have a strategy. Right? So what are those steps of securing your place? What is the strategy that you are going to adopt? Go ahead. Right? You have to forecast and evaluate the risks. Right? And then identify how are you going to reduce or minimize it. Simple. Right? So what are those steps that you are going to follow? Correct. First is identify. Identify, there is something called as IOC. What is IOC? IOC? Indicators of compromise. Right? What are those indicators of risk and indicators of compromise? Right? That's something you will have to probe. First, identify that. Unless you identify, how will you take the next step? So, identification, very critical. Then, articulate. What could be the possible risks to this application or to the firewall or to my switch or router? Right? Third, ownership of it. Who is the party responsible for it? Who has to fix application, security in the application? There is a separate application team. They are supposed to fix that. Right? You can't cover everything. Correct? So ownership and then remediation. How are you going to fix any security loopholes, etc. Right? These are the 4 steps of security strategy. Right? Assess. First is assess. Then, assess the security requirements. You have to look at what are the different assets available. Based on the assets, what could be the kind of vulnerability and threats. Based on the threat and vulnerability, you are going to identify the requirements. Next, you are going to perform a gap analysis. What is gap analysis? What is gap analysis? What is gap? difference in something to something. Right? What is that? What is that gap that you want to assess? So what is gap analysis? What is the current state versus what state it has to be? So the gap between the current state and what ideally it has to be secure. That is your gap analysis. That is your gap analysis, right? And then once you know what are the gaps, once you identify the gaps, right? You have to develop a strategy to fix those gaps. How are you going to, narrow those gaps? Bring it as close as possible. That is the next step, right? Then of course you are actually going to plan your transition to fix that gap. You are going to plan and implement the transition where you are going to fix the gap and you are going to move to the next step. Correct? One example for fixing these gaps, security gaps. You guys do it, even you have followed it. Once you get an alert, you have also followed it. What is it?
Use cases, I think Professor Vivek Borkar talked to you yesterday. There would have been certainly a lot of maths in this talk. And I was just telling your principal also was that, I don't know whether you know, Vivek Borkar was actually the JEE first ranker, All India first ranker in 1971. So, I'm sure he would have told you that. But I always keep reminding him about it whenever I meet him. How geometric thinking can allow for everything from better American elections, certainly need that, the deep trouble this year, right, in November, to better COVID planning. So this would strike much closer home, and it basically says that you should use geometry as the underlying model and metaphor for handling many of the real world issues. And I try to show this how this works in the world of databases. So you would all have done in your undergraduate course at some stage or the other, learned about SQL, which stands for Structured Query Language, which is also the de facto intergalactic standard for interfacing with relational database systems. So whether you have Oracle, or whether you have SQL Server from Microsoft, or whether you have DB2 from IBM, or you have Postgres, or any of these well-known or popular database systems, the interface to them is through this language called SQL. And what is very interesting about SQL is that it's completely different from all the languages that you have learned for programming computers. Those languages are usually what are called as procedural languages or imperative languages, where you have a target and you have to specify every step in the sequence to achieve those goals. So if you want to invert a matrix, for example, you have to give every step that you require to do with the columns and rows of the matrices in order to reach the final end goal. SQL is a marvelous language, very different. It's a declarative language. It just says, this is the target I have, you go figure out how to do it. Okay? So it's like you take an auto rickshaw from here and say that I want to go to the Majestic station. One way is to use the Google Maps and say I'll go like this, and reach there. If you just shut your eyes and told the auto driver, please go to Majestic, I don't want to know about the path, he will certainly take you there. It's just that he might take you via Tumkur, a slightly longer path through the scenic road. So this is the difference, is that it's just declares the objectives and not the means to achieve the objective. So to make that concrete, there's an example that you see here, which is this statements like pull out the name and the of the student and the titles of the courses. So this is a university database. There are 3 tables: information about students, information about courses, and register tells you which student is registered for which course. And in order to combine the information between these tables, you say that the roll number of the student should match the roll number in the register table, and similarly the course number in the register table should match that with the course table. So in case you have not seen the strange animal called the query execution plan before, here is an example that matches with the query that we were looking at earlier, where you are trying to pull out the names of students and the titles of the courses. So here, this is always going to be a tree of operators, which is evaluated in a bottom-up fashion. So the tables are at the bottom here, the student, the course, and the register table here. And what you see is that there are in-between operators like index, scan, sorting, hash join, and so on. So this is the tree. And each of these nodes that you see here is annotated with 2 colors. One is a The red color that you see here, which is called as cost, and the cost tells you how much effort does it take in order to do this processing. So for example, if you are going to do a sort operator here, it costs around 225,000 units of time in order to do the sorting of the table. And usually the cost is given as a aggregated value as you go up the tree. So the values keep increasing here. So essentially we say 220,000 here, it means it's the cost of the subtree, which is below this particular node. So that is one number. The other number is the green number that you see here, which is called as card or cardinality, which tells you what is the volume of data that is flowing from one node in this tree to the next one that is downstream within the plan structure. So here, for example, it's saying that 1,000 rows of the table are going to go from here to here. Or in this case, it's saying 10,000 rows go from here to here, and then they combine with this information, and then out comes the result. So again, the details are not very important. You just have a tree of operators. Think of it as like a water flow. Water is coming in from the various tanks that are here. The cost tells you how much effort does it take to open the tap. Okay, of course, today if you open in Bangalore, you get no water. It doesn't matter. How much effort is there to open the tap? Second is when you open the tap, how much water flows. So cardinality tells you the volume, cost tells you the effort. So if you look at any of the popular database systems, they all have their own secret masala to add to this. But at their core, they all have the same algorithm, and this algorithm comes from the late 70s. There is a famous paper from the IBM's Almeida Research Center, written by Patricia Selinger and others, which is called as the Bible of database query optimization. Those techniques are still used today. And the basic idea is that you come in with your SQL declarative query here. Will you give me 0 or give me partial marks? How much partial marks should I give you? Okay. How do I find the distance between queries? So now it's a very interesting theoretical problem. How do you say the distance between your query and mine? For example, you might have said age greater than 10, and the query is age greater than or equal to 10. It's a chota mistake. Should I give you 0 or 1 mark or 10 minus 1? What should I do? So there's lots of very, although the problem seems a very mundane issue, it's actually a very interesting intellectual problem. So they use this tool, they developed this. We use the same tool and said that we only know the extracted query. We will call that Sudarshan and call it the structured query. Hidden query is the student query. Now, Sudarshan will come up with carefully calibrated databases that are supposed to show any differences. So we will run all of these. If they don't show any difference, we say good, we have correctly extracted the query. If there is a mistake, then we know that something has gone wrong. So that's the tool that we are using here. And then of course you can do other tricks. You can generate randomized databases, and hopefully that if there's any semantic difference in the queries, it will show up on large databases. So you can also do those tricks. Yeah, so this is the final extracted query that you see here. This is what we have extracted on that example that I showed you. There is 3 tables, 2 join predicates, filter predicates, grouping, ordering, limit of 10, scalar functions here with renaming. Okay? So all the interesting features in databases here. What was the original query? The original query is what you see here. Okay? You can see that it's the same except for syntactic differences. Here it was student enroll course, here is student course enroll. But in principle the from clause essentially gives you a Cartesian product between the 3 tables, so ordering doesn't matter. So you see the same here. Grouping is also a set-based operator. It's a set of attributes. So S name, comma student identifier. Here it's student identifier, comma S name. But in order by, it's a vector and not a set of things. So it is a sequence. So it is score followed by name, score followed by name. So everything comes out together. So this is how you can actually do it. And we also have a formal proof of correctness that all this works under certain regulated conditions. Now, how much time does this take? So I'll just give you a quick performance numbers. This is on a 100 GB database on a very well-known benchmark called TPC-H. And you can see that on the x-axis is all the queries of the benchmark. There's 22 queries. We have picked a few of them. So this is query 1 to query 21. That's the label for the query. Y-axis is the running time. The running time, as you can see, is maybe of the order of around 5 to 10 minutes. You might say, is this very large? Because most people here nowadays say everything should come in milliseconds. But remember, this is an offline process. You are trying to look at a particular executable and deciding is it an SQL injection attack or not. So you're going to take it off, check it out, and then let it back into the system. So it doesn't have to be done in real time. So this is a few, as I said, less than 10 minutes. There's also another benchmark called TPC-DS, which is more recent than TPC-H, which is much more complicated. Even here, we can see this is in a few minutes, okay, which is perfectly acceptable for the kind of use cases that we have here. You can get extraction in a few minutes. And this is despite the fact that this executable is being run hundreds of times. Why? Because all databases post-minimization are small. 1 row or 2 rows or 3 rows. In fact, we show that for all the things we do, you never exceed single-digit number of rows, 9 or less. Every table will be 9 or less rows, which means that you can just run it even literally by hand. Okay, so the database is so chota that you can run it thousands of times. It takes virtually picoseconds to complete. Okay. So, yeah, and there's another benchmark called JOB, which is the join order benchmark. This actually uses the IMDb. Most of you should hopefully be familiar with IMDb, Netflix, Amazon Prime, FShareTV.io, so on, right? So IMDb is this TV and movie database which contains all the information about it. It's a very complicated database because there's lots of connections and joins which are there. Even here, you can see for different queries on the x-axis, y-axis is a few minutes of running. Yeah, and I also promised you that you can also do something which is very important in the database world is when you take imperative or procedural code written by programmers and convert it into declarative code which can then be susceptible to database query optimization. So this is coming from the Enki blogging application. This is what the programmer has written, which is in, as you can see, a code snippet written in procedural fashion. We can convert that to the equivalent SQL. Now, does it have an improvement? Here, the person who wrote the code would have done some optimization. It may not be as good as the database optimization because there's a huge amount of smarts that has gone into it. So, we saw substantial execution speedups on this version as compared to this version. Semantically identical, but performance-wise, this would take 10 seconds, this will finish in 1 second. Okay? We usually got 1 out of magnitude. So, there is not just aesthetic or cosmetic issues, there are also performance issues, which is why this makes it useful. Okay, so I'll skip some of these things. We have done a lot more beyond what I just showed you. Just think of a very interesting problem is I showed you how to do filter predicates saying age greater than 10 and less than 50 and so on. Suppose I asked you age not equal to 20. Okay, for some reason on religious grounds I hate the guys with age 20. Can you do that well? Okay, it's not an easy problem at all. Can you extract that clause which says age not equal to 20 by purely looking at input-output examples? Okay, you can also do, so far we are only looking at conjunctive predicates essentially connected by ANDs. You could also have OR conditions. In databases, algebraic filters are very common where it's not saying age greater than 10, you may say age greater than salary, which means on both sides there is an expression, which is not a constant. So that is also pretty hard, but you can actually do it. Again, the reason I'm highlighting this is every step we said, okay, this is the last step. After this, we'll give up because it won't work. But surprisingly enough, each new thing, by using some kind of creative cheating, you can actually get to the outcomes. And of course, this having clause, for those who are familiar with, is much harder. You actually have to change the pipeline structure itself. The original pipeline I showed you won't work with it. You have to change the pipeline structure. And then recently we also were able to do the union operator, which is even harder because it has multiple subqueries put together and so on. Okay? But as I said, it's a lot of fun because it's essentially a detective game. The use cases, we put that all later on. Okay? But it was just a nice intellectual challenge to say that without opening the box, just by looking at input-output, can you produce not an approximate connection, you have to produce exactly the right thing. Okay? Otherwise, all bets are off. You get zero otherwise. It has to match perfectly. So that's because you have ground truth and you can check. Okay? Yeah. So this is the revised pipeline. So I'll skip this part. Anyway. Yeah. So the takeaway essentially is that this is a new problem that was not being done in the database literature before, which we call as hidden query extraction. There are a lot of practical uses for it. In fact, one of the big uses for it, because I work with Microsoft Research to quite some extent, is to do something which I had not anticipated before, but is something very important for them. That is, how do you do database migration? So you are Satya Nadella. You want Elon Musk to say, move from Oracle to SQL Server. He says, sure, do it. It's not easy at all. Moving the database is easy. Moving the queries, very, very hard, because the syntax and the semantics are very different between the two things. I'll just give a very simple example. The word substring is used differently in DB2, Oracle and SQL Server. One person writes it SUBSTR. The other person writes SUBSTRING. Just syntactically itself there are differences between the engines. And then semantically also there are differences between the various engines in terms of what they mean. In fact, there are certain operators that are handled by Oracle that are not even present in the SQL that's handled by SQL Server and vice versa. So, database migration is actually a very important problem for the industrial vendors. Much of it is done by hand. Okay? So you tell the customer, I will shift everything, don't worry, just keep quiet. They shift the database file, trivially, no problem. Query workload, when you have to shift from there to here, there's an entire team which is doing it. It does about 70% can be done automated, the last 30% do by hand. It's pretty tough work. You can use Unmask to solve some of these problems because we are looking at behavior and not looking at grammar. So just to give you a similar example, if you look at Google Translate, normal translation earlier was saying that let me look at the original language and your NLP guru here. You look at the language, look at the verbs, look at the nouns, look at the adjectives, and then do a faithful translation here. Google Translate is completely impervious to grammar. It doesn't understand any grammar. It says, noun, what's that? Verb, what is that? What is it doing? It's looking at patterns through large training sets of saying, how was this translated to something else? So they'll take Deccan Herald and Prajavani and keep matching. Say, okay, this line matches. I don't understand anything of grammar, but I know how to translate because I've seen previous examples. So it does statistical translation as opposed to grammatical translation. In the same way, we are also doing, we are not doing based on grammar. That would have looked at the original query and saying, how do I translate from here to here? I look at the behavioral aspects. And through behavior, I can do translation or migration as opposed to doing it based on actually looking at grammar. So this is the kind of analogy that we have. There are of course still some interesting open problems. If some of you do decide to come and join IIC for a research program, you could come and work on these problems, and there's lots of other good stuff here. You can do it. If you need any more details, that's all given on our website, or you can send me an email. I'll be happy to bore you with more such material. I have 3-4 talks. There's a 5-minute talk, there's a 20-minute talk, there's a 1-hour talk, and there's a 3-hour talk. It's just the same thing. So whatever you are, based on your stamina, you can decide which one you can handle. Okay. And again, what I would like to highlight here is, always when we present this, they say, oh, you didn't take care of that clause. But it's like the GPT tools today. Many people criticize GPT for hallucinations and all that, saying, this question it did not answer well for me. Because if, for example, it has often awarded Padma Shris to people who have never even applied for it, right? You will find mistakes. But what is interesting about GPT is not how many things it gets wrong. What is interesting is how many things it gets right. That is the surprise factor. So here also, we know there's quite a ways to go, but what is not surprising is how much left. What is surprising is that we were able to reach this far. As I said in the beginning, I was told, select name from students, that's it. That's the only query ever in the world you'll be able to do this correctly, nothing else. But we have been able to go much further than that. So in that sense, look at the positive side and say, how far could you come? And there are many tricks and techniques you can use, things from matrices down to mutation to generation and so on. We have also used sampling theorems here for a different purpose. You can use solvers, you can use the checkers like Exdata from IIT Bombay. So many different ideas of computer science can come together to solve these problems. Yeah, so with that I'll end this presentation here. Any questions, hidden or otherwise, I'll be happy to.
So the idea of AI is try to go as close as possible to the human data, because
the kind of things. So it's more of a data-driven approach, right? If you see as a human brain, right? You are not programmed, right? You learn based on data, based on when you interact with the environment, right? Based on those information you learn over the time, right? So it's a more data-driven approach rather than programming, right? Because when you write a program, you know the pseudocode, right? What needs to be learned or what needs to be done, right? There, right? So already everything is planned, right? So that's more like a programming approach. But on the other hand, in AI, which is inspired from human brain, they try to learn from the data, right? So that's the main thing. Even for example, you have a function like y equal to f of x, right? And in y equal to f of x, if you don't know the function, right? For example, let me give you an example. When you start driving a cycle, right? You don't know what to do the algorithm to do that, right? You don't know how to handle this or this is a coordination between your muscles, all these mechanical structures and your intelligence and so on, right? So it's a nice closed control loop system, right? But you don't know how it will be driven, right? So it's more of a data driven, right? You fall, you take different decisions, and based on them you adapt, right? So it's more like a data driven approach. You learn based on what you get from the environment, right? You don't know, say, as an engineer, you know y equal to f of x, right? So what is f? You don't know. So now see, can you learn that mapping from input to output, right? So the mapping, when you learn the mapping, you don't know this f function. There was a second research in the 80s because of backpropagation, the emergence of backpropagation algorithms used for training of this model. And but now, because of this high performance computing or the resources of the hardware available, they're able to do that. And similarly, you have large amount of data. Right? So because of this reason, in this perfect time, you can have this deep learning is sustaining from my perspective. You are able to see this application, right? As I said, you already know ChatGPT. It's all possible because underlying is all learning deep learning with different model. And at the fundamental level, you are just doing matrix vector multiplication. X into W, that's it. And non-linear function. So the number of parameters are huge. So in ChatGPT, roughly the number of parameters is 175 million. Right? You can imagine how much storage you need. Right? Okay, so this is I'll skip this part, it's not too much interesting. Okay, so this I think this already you have felt recently in the recent past. It's going to almost in every aspect of this deep learning is touching almost every segment of your life and all the possible application, whatever you can think of, right? And from social media to sentiment analysis and filtering and in autonomous vehicle and transportation, financial services, healthcare, e-commerce, virtual assistant, which is robots and so on. So everywhere you will see this, and also in chip design domain as well as powerful these days. Okay, now some more basics because you don't have background as I learned this morning. So this is there are various models of network architecture. The simplest model is which we have seen the perceptron, right? You take an input, multiply, pass through the nonlinear function, right? Now if you scale many times, it's called deep neural network, right? So now you have many networks, but doing the same operation. You have matrix, you have an input, so you are doing matrix vector multiplication, right? And it's called deep neural network. But the operation is the same. You need only two basic operations: matrix vector multiplication and nonlinear function. If you have these two things, you will be able to do this. But this calculations are in billions and so on. Right? So that's why this has to be highly optimized for model. That's what people are calling an accelerator. So this GPU, that's what GPU is successful because they have optimized it very highly or very heavily, so you can have very small power and you can have better performance. Okay, from DNN, this is another. So next architecture is CNN, which is commonly used for images. So in images, generally you are very much important. I mean, you pay more attention to the local feature, right? So if you have some image and let's say this is an image, and if you want to extract the local feature of that image, right? So you do local computations, right? So there is a notion of kernel, that's called kernel or filter. So you talk about this, let's say 5 plus 5 filter, right? So you learn those 5 plus 5 filter and you will run across your image, right? and then create the next matrix. Okay? So what you are doing, you have a template, which is nothing but your terminal. You are trying to match with the template. And if it is high, the values of the single point will be high. Right? So basically the correlation you are checking. You are running across the image, and then you say, okay, what is this correlation comes out? And then you change this kernel, and then the kernel value change, and then again you make another matrix, right? So such that you have this 3-dimensional tensor you have, right? Okay. And then because now the dimension is huge, so reduce the dimension by doing the max pooling. So that's another term we use, max pooling. Right? So one of the first thing is called convolution, right? You might have studied plotting signal processing, the convolution operation in time domain. Right? Yes, in the spatial domain. And then you have max pooling, and then again do convolutional layers and max pooling. So here now you have convolution, max pooling, and then you have last layer which is like fully connected. This is basically your CNN engine, you call it. And it's pretty powerful for image related tasks, whether you want to do face recognition, object recognition. Make sense? Okay, so this is basic operation which you have, right? Imagine this is your image, and this yellow box is your kernel, and this is what you are convolving it, right? So this is the output convolved feature you will see. Okay? So this is just a cartoon to demonstrate how it works. Make sense? Now you can generalize it to many convolutional layers and many features and so on, just to increase the number of features and number of filters and so on. Okay, this is another computing stage called pooling. So pooling is basically you can have, let's say you have this big matrix and you do 2 cross 2 matrix, and you pool, you find the max out of that, right? So if this 4 element, the max is 20. If this 4, your max is 30. So this is how you get the max pooling. Similarly, your average pooling, you take an average of these 4 numbers, and then that's how you get the average number. This just you want to get the overall idea about that particular small location, because you want to reduce the dimension now, right? Because of where dimensions are, so to reduce that, you do this max pooling. And this is your the outcome of this pooling. So number 1, right? So you think about take number 1, for example. So it is trained for this kind of application, and that's whatever I explained to you. 3-layer neural network. It is a 2-layer and one is last layer, right? Then we take another example. So this is DNN, all fully connected, right? The second thing which I explained to you is more like a CNN architecture. So in CNN, you have convolutional neural network, right? You have convolution operations, you have pooling operations, right? So that's why you will see this is your image, right? These are your, so let's see again if you write number 2 here, from there, say also select number 2, right? And these are different features, right? You can see now the connectivity is very small. In the previous case, they all are connected to everything. But in image, you will be having local feature which you extract. So this is the local feature which is interesting at this particular pixel. Right? At different pixels, different local feature will be computed. Correct? So this is first convolutional layer, and then what we discuss is you have a pooling layer, right? Which will downsample. So then the downsample version of that same feature, so that you reduce the dimension. And the next layer, again you make it convolutional layer with different kernel, whatever this 5x5 kernel and so on. But again you have pooling layer. So you have two convolutional layers, 2 pooling layers, and then you have 2 fully connected layers. This is fully connected what we have just seen in the previous case. And this is much better than the previous version which I have shown you. So this is simple model, 3-layer neural network, 1, 2, and 3, or 2 hidden layers. And you can see here it's all connected. This neuron, every neuron is connected to all the other neurons. In this case, it's very local connection. You can see here, right? It's very local connection. And this performs much better than the previous one. So this online you can play with it and understand how it is happening. Let me play another thing to give you some more idea. So now this is your book. So now this is very simple network. Again, you have this two inputs, x1 and x2. You have few 10 neurons or 1 million layers. There is only 4 neurons, and then you have 2 output classes. Now your goal is you have this class, you have this inputs, right? This is in blue, this is in orange, and this is what we are interested in classifying, right? It's not a linear classification, right? It's a non-linear, right? So now, and this is your input x1 and x2 because they're 2-dimensional points, right? x1 and x2, 2-dimensional points, right? So one point is x1 and x2, right? And then another point is again different x1 and x2 and so on. Right? So and now we are using this 10h, 10 hyperbolic as a non-linear function, which I told you, right? The non-linear function is important. If you don't put that, you'll see the effect of that, what will happen. And this you can ignore at the moment. So now let me run that and see how it works. So you can see quickly it just converts and it's able to classify it according to blue and the orange, right? It's able to do that quickly. Now, if you see here, if I change the activation function to linear, what will happen? What should happen? Does it work? Will it work? Huh? With linear function, you will not be able to classify, right? You can't find the linear boundary because this is non-linear curve, right? And that's what you should expect. So if you run that again, whatever you do, even if you give more and more data, it doesn't really matter. It won't learn. And that's why after so many iterations, it's not able to find the boundaries. You are seeing this is the kind of thing. It will just saturate at one point and you will not be able to decrease or convert to the lower pattern. Right? And that's why this activation has to be non-linear if you want to do it. Doesn't matter what non-linear, but it has to be non-linear. Even if you do, for example, value, which is a non-linear, value is what? Half a rectification, right? If it is negative, it is 0, or it is positive, right? It's a non-linear function. So even with that, it should learn. Because it's a non-linear function. So it has learned function. Even if you use sigmoid, okay, so now from Hamel-Harder perspective, what are the different hardware available to you? One is CPU, right, which is simple and which has you can have complex programming in that, but it is a single ALU, right? You have a single ALU, you have memory, and then you have to read right from the memory. But very simple, you can write in the high level language and you can access it. Second is the GPU, right? Which is, what are the difference between CPU and GPU? Anyone here? At the architecture level, what is the difference? Yes, but what? Huh? Correct. But here you are single CPU, here you have bunch of cores, more cores and thousands of those cores. But the architecture is still the same. You have a small ALU and then you have small memories and so on. But the number of cores are huge. And that means the parallel processing, like you said. But still it has a limitation because still at the core level it's still it's a sequential. So the next people have come up with the FPGA, right? So FPGA again is a parallel distributed system, right? You can directly code at the very low level. RTL, you can control. So it has much more power and speed efficiency as compared to GPU and CPU. Now the best level is ASIC, so you can have full control. You're writing mainly for that. That's what you might have seen this TPU from Google they have built, right? That's a processing unit, right? It's a complete ASIC they have built it mainly for this purpose. The very Cerebra and the ways people are building mainly for AI experience, right? So in terms of efficiency, this would be highest efficient. In terms of power, performance and area. Then the FPGA comes in. The FPGA is already pre-built, since right, you just need to reprogram it. But still it gives you the power of, in terms of power as compared to GPU and CPU, which is much more optimal. Okay, but it has very high entry point, right? For example, as a computer science background, it would be difficult for me to go to GPA. Right? You have to have some basic skills in VLSI, then only you'll be able to. Same for SAT, you have to have a student in VLSI, then only you'll be able to. But GPA and CPU doesn't require an expert. Right? You can write in high level language and C, and you'll be able to compile it. Right? So the flexibility wise, CPU and GPU is much better than FPGA and SAT. And in terms of cost per unit, if you are talking about millions of those chips, the cost per unit would be much more efficient for us because you are making that mainly custom accelerator mainly for that application. CPU and GPU are more general, you can do any kind of workload on that, but these are more custom and specific. Right? So this is the flexibility wise, you have to go from right to left, from SAT to CPU, CPU is very flexible. From efficiency in terms of power, performance, and area, SAT go to the best. And then cost per unit, of course, SAT go to the best because you are making millions and millions for the customer application.
Yesterday your XAMPP server was active, right? The local server. Just go to that same server, it should be active right now. IoT. Just open that and can you find one zip file? Some grayscale, something is there. Can you quickly download that? Okay, quickly download that. And can you quickly install something like PyCharm or something to run a Python file? Read that camera data or something. There's a program in that, right? Just try to understand what's written in the program. We'll do the training everything on the cloud, but I want you to visualize the camera feed right now. Let's write a program to, see yesterday we have spoken about serial communication, right? So what does the serial communication do? So what are the two devices that we were trying to communicate with? So you're trying to communicate between your embedded board and PC, right? So now what we are going to do is that the camera is going to send those images. We are going to receive it in our PC. We are going to send that into a Python file and we'll recreate that image and see what the image looks like. Okay, so download that zip file and also I'm assuming you guys know how to do that. Python community edition. Install the Python community edition for that. Python community edition. Something for your Windows system. Quickly install Python community edition.
I welcome you all for the valedictory function of 12 days refresher course, which was started on 25th of March and we are concluding it today. And we have very eminent speakers from IISc Bengaluru, IIT Bombay, then Central University of Punjab, and also IIT Bombay Vivek Borkar sir was there, who was a topper. We came to know by Harishta sir that he was a topper of JEE first rank holder. Actually we were not knowing that, but once after coming here we came to know the value of so many dignitaries. So we are thankful for all the dignitaries and also resource person who have contributed to the refresher course successfulness.
So 2 weeks is a good time to know the subject in detail. And in fact, when it is an offline session, it is always good. So that way, I think, I am sure you must have learned a lot about it. And then a lot of speakers, even Madam mentioned, I think they are all very reputed institutions from IITs and all that. So I'm sure it must be a very wonderful session. Now presently when we talk about the educational institution, the entire pattern has changed. Earlier it was only about taking the regular classes and all that, but now everybody, even the students and even the faculties, even the head of the department and management, everybody is like, we have lot of challenges and it is not the same. So that way I think these all kind of programs help us to build the network, not only the content of the course but also it really helps us to know the people more in detail, and even in future when we want to go for a more of a collaboration, and these kind of programs really helps.
And more so, we have all assembled in this time after a very long period, maybe around some 2-3 years. We never had a offline course due to the pandemic, and now we have come back to understand what it is. And I am definitely proud for a very simple reason that even I belong to the same department as Dr. We are able to do this type of a course. I hope some of the good takeaways for outside participants would be, you have seen Bengaluru around. We also saw you having gone for an excursion trip which Madam had organized and taken all of you. It was very refreshing at least to see those photos from wherever you were. I wish you all the best, a happy learning, and for those from outside Bengaluru, please do visit Bengaluru again, and if you come, we welcome you to BMS IT. Thank you.
So we have learned so many concepts from different experts, and other than that, best part was discussion program and food. Madam, we enjoyed a lot. So thanks so much for the opportunity. And finally, I thank our management for supporting to attend this event and organize this event. So thank you so much.
It was very helpful. We had teachers, faculties from different fields and technologies. We got to learn a lot of information from it.
It's very, actually for me it's very, the content is very advanced, so it was very, for me it's very difficult, but session is overall nice. So actually in the BMS I visited in the 2017, Dr. Jagdish sir is organized one FDP on that day, maybe in the CMD computational fluid dynamics, I attended there.